Hello everyone, just going to do a small update here. I'm not on the tripod because I don't have this laptop upstairs yet. I don't know where I can put it there. But I said in the last video I was going to check and see if we could use the 400 kilohertz version of the I2C library. And this here, actually we're doing it right here for a reason. This usually puts you into the 400 kilohertz here for the I2C on a 16 megahertz CPU. I've done it on my Arduino Uno in the past and whatnot. Now, the PCF chip that we were using the last couple of videos has stated that it doesn't, or at least in some of the docs, most of the docs says that it only works on the 100 kilohertz I2C bus, but here I'm pushing it to 400. And the thing is, it's working. I can't really stay still enough, I think, above here, holding this camera to let it reset, because the other thing I've noticed is the performance of the sensor seems to also have increased at the higher clock speed. Oh, maybe. Oh, there we go. Just move my hand again. So you see, that's all working. And again, I'm using the newer expander library. And the thing is, you have to call that. If you notice, there's lost my focus or something. There we go. If you noticed, I called the TWR setting override before I called serial, and that was fine. The problem is, the moment I called this, it must have invoked something that reset this value, because once I reset this again down here, it seemed to be fine. And then you can go on and do this. This is that pin mode thing that I mentioned. Input pull up might be carrying out this automatically, but forcibly setting it to input and then writing it high always works. It worked every time, every boot cycle. There's something funky about this. I think it's just legacy. If you look in the documentation for this, I think it's just legacy supported. You still really need to do this for that little chip. And that's our little friend here. It's just the early morning, and I haven't really gone upstairs because Heather's still sleeping. But I haven't really changed the diagram. You bear with me again here, some super shaky video. I will reduce this down and we'll have a look here. All I'm doing is running the I2C bus wires directly over. I don't even have any pull-ups on it, not even at this high speed. They're so short it doesn't seem to really matter. If it was a longer run, then you definitely want pull-ups. But I'm staying like under 3 inches, I think. Probably not even that. All the address pins are pulled to ground, directly connected to ground, not even using a resistor on them. So that gives you the address and hex of 20. The PIR is sharing the positive lead with the LED. The LED is passing through a 430 ohm resistor. It's an older LED and it seems to be maybe a little bit too much, but it's fine. We just needed that visual indication. I'm not sure if the 4.7 k ohms, I'll actually double check and make sure it is 4.7. It might be 4.3 kilo ohm. I think it's recalling 4.7 k ohm resistor pulls this wire to ground because the PIR triggers high. If you've used the internal pull-up and written this pin, the IO pin 1, to high, you won't ever detect this thing triggering. You won't hardly never see it. I mean, when it goes low, it's just off. This would stay high. So what you need to do is pull this line low enough that it drops below the logic threshold for a low. So what I'm going to do is I'll probably put a 100K trim pot in here and turn it until I get the value that's well inside it, and see how close I was on my 4K. We might be able to go with a bit better resistor. But You wouldn't want to just pull that down to a short though either, because at a short no data will flow, so it has to be something. What this does is then when this goes high and that goes to a high, it's just enough to kick this line over the threshold for a logic high voltage. And on top of that, for some reason pulling this slightly low, the response time of this has gone up. In fact, it's much smoother even today, even increasing the frequency of this past the supposedly documented 100 kilohertz. If you go into the wiring or one of the PDFs that I have, most of them say 100, but I think it's because they're old. A lot of the new ones say that these things are good for 400 kilohertz. So I thought I'd just try it today, and that's what we were doing in the code. Let's turn it back up. It's been running here for a little while. Oops. Just knock everything sideways again. If I can get that to focus. It's, of course, seeing me move this camera around. And if I hold it still here, if I can hold us still enough for, oh, there we go. You guys can't see, but the LED turned off. And now I'm moving the finger. So, it's working perfectly fine. In fact, I'd almost say better this morning. The other thing I found out, let's see if I can get this to focus in here. The other thing I figured out is in a fairly cold room with the heater on this time of year, it can actually see large volumes of hot air moving. I mean, that would make sense, right? I'm just going to move my hand here so we can, there we go. It was very quick. Unfortunately, you didn't see the output over serial unless you saw the little serial light flash, but it responds much faster. So the thing is, the infrared sensor needs to drop down to room temperature, the whole body of it. And I guess with me handling it and moving it and also touching it, the casing of the sensor was dropping down. So that needs to be room temperature too. It's all important, and it's good to have any sort of blowing heaters, such as that heater over there. Not focusing on the daylight here. Blows out a very large warm air mass, and it was actually seeing the air mass of the heater. And that's why it was also behaving a little better upstairs, because the heater in the room upstairs is a little more stable. And again, I'm not sure how this lighting is picking up, because this is just the daylight here coming in through a window in the far corner. But as you can see, it appears to be behaving well. I thought I would just put this video up, supplemental to the last one. Trigger it again. There we go. Anyhow, so there we have it. 400 kilohertz bus is working fine, and I'm pretty happy with that. In fact, it's quite fast. It's fast enough, and it'll be interesting to see if on the ESP8574P if it supports any faster I2C buses, and if this thing can handle it. But 400 is plenty good enough. In fact, I was still happy at the 100, but 400 is really good. I could get a CNC working with Adafruit Motor Shield at 400, and it was reasonable. Not awesomely fast, but reasonable. So 400 from that is great. That'll help if any of you guys need pins for making your own LCD shields. If you get a bunch of these chips in a drawer, they pretty much wire directly to those cheaper LCDs that don't come with the I2C drivers. All those boards are really just one of these chips on a little thing that you plug in. Anyhow, that's another point. This is working as expected now, and pretty happy with that. Hopefully my next video I will have this code tied into an ESP module, and then we'll look at having it possibly updating a web page status, and look at some of the higher end ESP code later on. A few of the other YouTubers that I follow have also been doing some interesting work in the Internet of Things regarding the ESP modules, so it would be nice to maybe integrate some of the work that I've seen them put out and some of the helping files that they've put out as far as making web pages run from your ESP for both cell phone and desktop. It really would be kind of nice to have the home system running from our phones, and My wife and I use Samsung Alphas, which are Androids. This video right here is actually being recorded, and all my new videos are recorded on a Samsung Alpha, which I've been myself pretty impressed with. It's beat all the other cameras in the house easy. I'd like to get my old Samsung, which died a horrible death, up and running. It has a pretty good camera in it as well, but not as good as this one. But it would be good for a backup camera. Anyhow, again, we'll just show that. You can see it's working quite well. I've had it running for a couple minutes now. And I'm just going to reset this for those of you, show you that's working on a faster code. There we go. It's only going to take total maybe 5 or 4 seconds to get past the boot and the warm up. And then what I had it do is report the 2-wire bit rate just before calibrating the sensor, and remind me that I'm using that modified version. But pretty happy with it. And again, thanks for watching.